So solving inequalities. Solving inequalities are the same as solving a regular equation. Like if I had 10 plus x is equal to 13. It's the same thing. The only difference is this is changed into a greater than instead of an equal to, except for one rule. So the one rule that makes it different is if you divide or multiply both sides by a negative number, you must flip or switch, however you want to say it, the less than to a greater than or vice versa. So if it's a less than, you flip it to a greater than. If it's a greater than, you switch it to a less than. I'll show you why in just a second, but I'm going to go ahead and do this example. So if I have 10 plus x is greater than 13, remember I always circle my variable, and that's what I'm trying to get by itself. So the opposite, right now it's 10 plus x. It's a positive 10, so in order to make it cancel, I would need to subtract 10. So then it would be x is greater than, and 13 minus 10 would be 3. 13 minus 10 is 3. So my answer is x can be any number greater than 3. It could be 100, it could be 4, it could be 3.5. Any number as long as it is greater than 3. Okay? Another example. If I have 10 times x is less than or equal to 90. And I wrote 10 times x. I really should have just left it as 10x. That's typically how you'll see it. So I'm going to go ahead and put white out. You'll normally just see it as 10x, and that really shouldn't be that far apart. But remember, 10 times x, or 10x is the same thing as 10 times. That's not a period, that's a times. So 10 times x is less than or equal to 90. If I want to know what just x is, I need to do the inverse operation. So the inverse of multiplying by 10 is to divide by 10 and divide by 10. So x is less than or equal to 90 divided by 10 is 9. So x is less than or equal to 9. It can be any number less than or equal to 9. So think of a number less than 9, and I want you to plug it in here. So I'm going to think of one, I'll do 6. So is 10 times 6 less than or equal to 90? So 10 times 6 is 60. 60 is in fact less than 90, so that works. This is just a way to check, and I'm also showing you why this solution works. So if it says is 6 a possible solution, well, 6 is less than or equal to 9, so 6 works. 9 would also work because 10 times 9 is less than or equal to 90. So 90 is less than or equal to 90. Okay, now those were just one step. Now we're gonna go ahead and do two-step. So if we have x, sample 3, if I have 4 times x plus 4 is less than or equal to 40. And I'm probably going to run out of room. I didn't think about that. I should have left myself more space, but that's okay. So remember these parentheses right here, you always have to distribute first. So it'd be 4 times x, which is 4x. 4 times 4 is 16, less than or equal to 40. Circle the variable. So I need to leave that, isolate this. So the first thing I need to do is find the inverse operation of adding 16. So the inverse of add 16 is subtract 16. So it'd be 4x. See, I told you I was running out of room, darn it. 40 minus 16 is 24. And I'm just move right here so that I have enough room. So 4x is less than or equal to 24. Okay, then since it's 4 times x, Remember, anytime a number and a variable are right next to each other like that, it's multiplication. So the inverse of multiply is divide. So divide by 4, divide by 4. So x is less than or equal to 24 divided by 4 is 6. So x can be any number less than or equal to 6. Okay. Our next example, this is going to have that one rule that makes it different. So if I have 12 plus x less than or equal to 4 minus 3x. So this one is a little bit more challenging just because we have the x's on both sides. And I am going to work it both ways. So if you circle the variable, you notice there is a variable on both sides. So we need to do the opposite of one of them. You can either move this x or you can move the 3. I personally like to make them positive, but for the sake of that different rule, I'm going to show you this way first. So I'm going to go ahead and subtract the x and subtract the x. So then I would be left with 12 less than or equal to 4. Now, negative 3x minus x. Negative 3 minus 1 would be negative 4x. Circle the variable again. Make sure you circle it with the sign. Now, this is a positive 4. This one is positive. This is what I'm trying to get off of that side, so I need to subtract 4 and subtract 4. 12 minus 4 is 8, less than or equal to negative 4x. Okay, now it's negative 4 times x. Notice it's not negative 4 plus x, or the subtraction sign isn't between them. Since it's a negative 4 times x, you have to divide by a negative 4 and divide by negative 4. Now, this is where that rule comes into play. I'm going to go ahead and highlight it. If you had enough room and it's on the same page, I would draw an arrow. So I'm going to go ahead and draw an arrow up to over there. And then highlight this. So I need to flip this symbol to this symbol. So it needs to change to that. So then it would be 8 divided by negative 4 is negative 2, greater than or equal to x. So it's negative 2 is greater than or equal to x. You could also rewrite it if you like writing it with the x first. Notice the little portion is pointing to the x, so you need to write it like that. So I just rewrote it so that you can read it as x is less than or equal to negative 2. Now, I'm going to work this same problem. I'm just going to do it the opposite direction up here. Instead of moving the x, I'm going to move the negative 3. So if we have 12 plus x is less than or equal to 4 minus 3x. And I'm going to do the same exact stuff, just this time I'm going to go the other direction. So I'm going to add the 3x and add the 3x. So it'd be 12 plus 1x plus 3x is 4x, less than or equal to 4. Go ahead and subtract the 12, subtract the 12. So it'd be 4x is less than or equal to 4 minus 12 would be negative 8. 4 minus 12, if I gave you $4 but I owed you 12, I still owe you 8. Okay, it's multiplying by 4, so divide by 4, divide by 4. So x is less than or equal to negative 8 divided by 4 would just be negative 2. Now notice, there is a negative dividing right here, but it's when you do it to both sides. I have to divide both sides by a negative number in order for that rule to apply. Now, if you look at this answer and this answer right here, notice they are the same. It was just already written with the x first. That's why you have to flip that sign, because you wrote it, you changed the x to the other side, so you have to flip or switch the inequality. So that is why that rule applies. Okay, so x is less than or equal to negative 2.